Welcome everybody to the OrcaFlex 11.1 user group meetings. And my name is David Heffernan. I'm in charge of software development. And with me today, I have also James Pell and James Carlisle, senior software developers, and they're here to help handle the webinar, maybe answer some questions, especially if anyone asks hard questions that I can't answer. So, as you know, we normally run these meetings in person, but the pandemic has pushed us online. One benefit of that is that the attendance isn't limited just to the physical venues we normally present at. So a very warm welcome to anybody who, because we're online, is able to join us for the first time. And of course, an equally warm welcome to everybody else who has maybe attended before. So, as you know, these meetings were originally planned for the end of 2020, but we delayed them until now because the OrcaFlex release itself was delayed until a couple of weeks ago. Now, I can't blame that delay on the pandemic. The delayed release was simply because the new restarts feature was a huge undertaking, and we have spent the last 3 or 4 months testing it, which has been a really, really challenging task. It's really important to test things well before their release, and we found a whole bunch of issues. I mean, we found some straight bugs, but we also found issues where we hadn't maybe quite realized how best to design the software. So by taking the time to let the software be fully mature before releasing it, I think we've got a better quality product. It does mean, though, that we are planning to release 11.2 at the usual time, October, November this year. So that's a much shorter development cycle than normal. So whilst I think 11.1 has been something of a blockbuster release in terms of what it contains, 11.2 will be quite a bit more modest as a result. Now, if anyone has any questions on what we're presenting, then please ask them in the Zoom Q&A. James and James will either answer them there with text if that's possible, or if not easy to answer in text, then we might save them up to the end of the presentation and answer them live. Right. So I will now just give you a little bit of an intro to what we're talking about. This webinar is about the restart analysis feature. We have webinars on OrcaWave tomorrow and then on Thursday, although it might be Friday depending whereabouts you are in the world. Another session on the remaining new features in OrcaFlex. It's still possible to sign up for those sessions. Now today, we're talking about restarts, which we will cover towards the end through a series of examples. But before we can get onto those, we need to cover some other features that we've added in order to facilitate restarts. So that's those are change tracking, variation models, kind of related, and then also some new simulation stage and time data. Now, I need to reorganize my windows here a little bit. Okay, now I'm going to just point out in OrcaFlex itself the what's new topic in the help file. This is your starting point whenever you get a new version of OrcaFlex. Come here. There's a long list of all the new features and hyperlinks into the main part of the documentation, telling you all the gory details. By necessity, in a 1-hour presentation, I can only give highlights and a high-level overview of what's going on. If you want to know all the details, come to the documentation. Okay, so I mentioned that before we can actually talk about restart itself, we need to talk about other features that facilitate it. And why is that? So in order to kind of explain that, I want to say what a restart analysis actually is. So a traditional OrcaFlex analysis starts by OrcaFlex finding a static equilibrium for the model, and then typically followed on by a dynamic analysis, either a frequency domain dynamic analysis or a time domain dynamic analysis. And with a time domain dynamic analysis, there is a build-up period where the dynamic loading is ramped up, and then the main body of the time domain analysis. Now, a restart analysis differs from that. Its initial conditions are determined by a prior analysis. The prior analysis can be either static or dynamic, and the restart analysis itself can be either static or dynamic analysis, or potentially both, in both cases. The input data can be modified in a restart analysis, and that is what really gives it some power. Without that capability, the feature would be a little bit useless. It would just be like extending a simulation. So because we can modify data, we had a goal that the input data files for restart analyses just contained the data which had been modified. The rest of the data should be inherited from the parent model, which allows you to change common data in the parent model and have it flow into the restart models. And in order to facilitate all of this, we've added change tracking facilities for input data to support this. So I'm going to start by giving an example. It's the classic example we always show at these meetings: vessel with a line attached. The wave is a regular wave with just default height and period. The line, I'm going to point out, it has a length of 220. Now I'm also going to, in the same directory, I'm going to show the other file that I have here, which is called variation. And it's a YAML text file, and it's an OrcaFlex text data file. And this is not a new feature. The fact that OrcaFlex can read these files have been used for many years now for automation. The first meaningful line after the comments says that the base file is called base.dat. That's the model I've just loaded. When OrcaFlex processes this, it loads that file, and then it makes these three modifications. It changes the wave height, the wave period, and the line length. And if I load this file into OrcaFlex itself, I can look at the places where the data has been modified. I can see the new values, but I can also see highlighting to indicate that this value has been changed. So that's the tracking of changes, or change tracking. Be familiar with it in programs like Word. For the line, again, we can see that this was the new length specified in the variation file, and also notice that these items, which are derived from the root of the primary data item, these items have also changed, and that change has been picked up by change tracking. I can change this. I'm going to change this to 200, and I'm going to change the wave period to 18, and I'm going to save it again. And in previous versions of OrcaFlex, if I'd done that, the entire model data, all the REOs and everything would have been saved to the text data file. But you can see that still only the modifications are saved to the data file. And this is the new feature. Change tracking allows us to keep track of which data items have been changed and only save those to these variation files. So this in itself is actually a really big benefit. As an opportunity to nail down some terminology, the base model here is what we refer to as the parent model. The variation model is the child model. A child model has a single parent, but parent models can have multiple children, and a model can be both a parent and a child. And all of that allows for chains of variation models and chains that may indeed branch. If I look on the general data form, we have some extra information that's new in 11.1. We see the model type, variation model. If this was a restart, that would say restart. And we also see the parent file name. Okay, I'm going to show you how to create such a model. Previously, in older versions of OrcaFlex, you would have had to do that by hand in a text editor. But now in OrcaFlex GUI itself, I do File, New Variation Model. I must specify here the parent file. So this is a little bit different from when you normally create a new model. You normally create a new model and that's it, there's nothing more to do. But here, I must always specify at the point of creation the parent file. I'm going to save it. I'm going to call it variation 2. I'm going to load that in my text editor. I can see I've made no changes, so there's no modified data there. If I drag the data around a bit, save it, I can see those changes. Now I'm flipping between text, the text editor and the program, but I can also, the model menu, I can also do edit data as text, and I can see that data. Now that's very useful for a variety of ways. If I have a lot of variations, maybe a lot of objects, and there's maybe handful of changes made. If I want to find which of the data items that have been changed, well, I can just look in here and identify quickly just the data items that have been modified. If I want to change those, maybe I'm going to remove these two and set that to exactly 40. I can actually edit that in here. Press OK. And I see that was the value minus 25 in there, and the value I set there. So it's sort of two-way tool. You can edit in the GUI, you can switch to text mode and edit in either place. Our existing Excel-based feature for automating pre-processing using YAML variation files, that is fully compatible with this new functionality. And indeed, you can create the YAML template files directly in the GUI, which makes this automation easier to use. I mean, previously you would have to fiddle around and try to get the syntax of these files just right, and sometimes for certain data items that could be a little bit more tricky than others. Now you can let the GUI do the hard work for you. Before I move away from this, I'm just going to mention a couple of new context menu items on the data forms to support or go along with this new functionality. We have restore selected items to original values, and if the value has been modified, I'm offered this, and I click on it, and we change the data back to the value that was set in the parent model. I can, even if a data item has not actually been changed, I can mark it as being changed. Now this is quite an esoteric feature that is really only relevant for a handful of situations relating to restarts. I'm not even going to cover it at any point in the presentation today. It's really quite an advanced feature. So I suppose I'm mentioning it to give you license to ignore it until you come to need it. You don't need to worry about what this does. It's really only for quite particular specific scenarios. And certainly while you're learning the feature, you don't need to worry about this. And the final new item is not really related to restart at all, but I think it's important to mention it. It's not uncommon when you've been dealing with maybe a tricky statics convergence. You've increased the damping, maybe added the iterations. You've done the heinous crime of increasing the tolerance so that it converges. And at some point, sometimes you decide, look, do you know what? I want to go back to the beginning and start again and try this differently. And in previous versions of the program, there was a button around here on the form called Set to Default, and it set all of these parameters back to their default values. That button's disappeared, and before anyone panics and gets upset that this critical functionality is gone, it's still present, it's just handled in a different way. I can now select a data item, right-click, and then say Set Selected Items to Default. Or I can select a range of them and set them all back to default. It works across the program, so I've got it here on this option box. Drop down. Again, I can set it back to default. So this feature works across all types of data. Having added it for all types of data, there's no sense in keeping these bespoke buttons. There was one on whole system statics convergence. There was another one for line statics convergence. There were a couple of others littered around the program. They've gone now and replaced by something that I believe is better. Okay, we're nearly there to actually talk about restarts now, but before we do that, I just want to mention some changes to the simulation stage and time data. And that data has kind of migrated to a new page called Analysis. These data items, they've been all over this data form over the years. Hopefully, they've found a permanent home now. We can choose to whether or not we're going to perform statics with this switch, or we can choose whether or not we're going to perform dynamics. And we make this choice here now rather than at the point where you perform the analysis, because particularly when you've got chains of restart, it's much more convenient to build it into the model rather than take the decision when you come to run the analysis. So that's why we've made that change. You can disable both, which is a little bit pointless because you can't actually do anything at this point. So you generally will have one or the other or both set. Now, in previous versions, there had to be a minimum of 2 stages, and that's no longer the case. You can now have only 1 stage. And again, in previous versions, the first stage was always numbered 0 and was always a build-up period, and it always ended at time 0, so that negative time represented build-up. Well, now you have flexibility I can maybe say the first stage is called 3, and I can say that the simulation is starting at time 20. I can also choose when I ramp. So let me just fiddle this around. Oops. I'm going to say that my ramp runs between 5 seconds and 15 seconds. So it actually spans 2 different stages. If I look at this now, and the ramp result variable, which I think is new in this version, you can now see ramping between 5 and 15 seconds. And even better, we can, if you want, we can ramp down as well as ramping up. And this could be useful for some restart scenarios. And the way you do it, actually, it may be a little bit quirky the first time you see it, but I think actually it's quite a neat way of solving the problem. You would just arrange that the ramp finish time is before the ramp start time, which sounds a bit odd, but it just turns out to be a neat way to have a simulation where the ramp ramps down rather than ramping up. Okay, I think I've said everything that needed to be said on that, and now I can start talking about some restarts. And I'm going to begin with the most very basic example. This is an example that that can be found in the documentation. Let me find it. Okay. So what I have here is a 3D buoy sitting in space here, and I want to have, I've actually disabled statics. I don't want to even bother thinking about finding a static equilibrium rather than removing all the degrees of freedom or excluding the buoy from statics. I'm just going to say don't do statics, just start from the reset position, just jump straight into dynamics, and the buoy is just going to fall under gravity. And I have a 2-second stage running from time 0 to 2, and there it is. Not very exciting. The buoy falls under gravity. Now I'm going to create a restart analysis. Again, I have to specify the parent model for the restart, which I do here. I'm going to save it. I did Control S then. I should have clicked on the save icon, but I did Control S just so that you know what I did to summon that box. You know, obviously I use the keyboard shortcuts a lot, but for doing a demo, it's much better to use the buttons. I'll try and do that for the rest of the time. Right, let's save that. Again, well, I can just look at it here. No change, nothing much happens. Now, what I need to do, I need to make a couple of changes. At the moment, because I'd specified the start time and the first stage in the parent analysis, they are inherited by my restart. And I don't really want to repeat stage 1. I don't really want to repeat time 0 to 2. So if I set both of these values to tilde, in a restart analysis, this means pick up from the end of the parent analysis. So in that case, it means that the stage start is now 2, because that was the time at the end of the parent, and the stage number is stage 2 because in the parent the stage was numbered 1. And I would note here that we have the model type as restart analysis and the parent file name is listed here. Note that this is a DAT file. We have the data file here. Now and it could be a DAT file as it is here, or it could also be a text data file, and it's commonly a text data file when you have a chain of restarts because your restart files themselves tend to be text data files. But when I actually come to try to run this, what OrcaFlex is going to do is it needs to get the state from the parent analysis, and it gets that state by loading the sim file for that parent analysis. So it takes this file name, it changes the extension to sim, it loads that file, it transfers across position, velocity, acceleration of all the degrees of freedom and actually some other state as well potentially, and then starts the analysis. That's really how a restart works. Now if I try to do that here, let me just save that, and I can see these are the 2 changes I made on the general form. If I try to run that, we get an error message. We get an error message because we haven't yet run the parent analysis. So that's to be expected. So I could load the parent analysis, run it, save it, then come back and load the restart, run it and save it. But it's, typically you're going to do this through the batch processing form. Now I could come in here, I could select both of these files because I need both of them to run, add them, that's fine. But if I have a lot of files that I want to run, it can be awkward to go and find them all. And maybe I only want to run one particular chain. Well, there's a checkbox here called Include Restart Parents. If I have that checked and I select the ultimate child in the restart chain, then OrcaFlex will go and also add all of the parent models in that chain. And when I come to run the batch, OrcaFlex is intelligent enough to understand the dependencies, and it will make sure that all parents are run to completion before the children start running. I can click on run to see that happen, but it's such a simple model. It happens so quickly you don't actually see that. We'll see that a little bit in one of my later examples. Now I'm going to load the generated sim file. I'm going to look at a replay, and this is just the replay of seconds 2 to 4 of the restart. But if you notice, there is an additional option in the replay type called restarts, and if I select that, I can choose which files in the chain to include, and I can actually run a replay for the entire restart chain, or whatever portion of the restart chain I want. Similarly, if I bring up time history, I'm going to look at Z and velocity and acceleration. I can say include the parent models. I can select which files I want. I can choose which period within the overall chain, and then when I look at that, I get 0 to 4 seconds time histories, which actually comprise 2 distinct OrcaFlex simulations, the parent 0 to 2 and the restart 2 to 4. And we can see that the velocity, acceleration, Z, they're all continuous across the chain of restarts. Now I'm going to reset this model, and I'm going to change the X coordinate to 20, and we see that it's highlighted in orange as being modified. Also note that the Y and the Z initial positions are highlighted, but they're highlighted in a different color. They're highlighted in blue, which indicates that this data may be ignored. Why is that? Well, it may be ignored because, and in fact in this model it is ignored, and it's ignored because the initial values in the restart for Y and Z, they come from the parent analysis. It would, the whole point of the restart is to pick up the position, velocity, acceleration, and other simulation state from the restart. So we don't want to just go and impose positions from the data here. We want to use those from the restart. However, I'm actually saying in this case I want to impose a data change, but just in the X coordinate. So if I run that now and look at I'll look at the same graphs, but I'll also add in X. I can see again that acceleration, velocity, Z are all continuous and inheriting and picking up values from the parent. But Z has a discontinuity, a jump from 0 to 20 at time equals 2, which is the join between the two analyses. Okay, let's move on to a slightly more complicated example, although not very much more. I have my classic model with my vessel and a line, and I have a regular wave, period 12 seconds, and on the general data form for the simulation data, I have, it's really a classic OrcaFlex analysis, a build-up period that's stage 0 with 2 wave cycles, and then 4 wave cycles in stage 1. And I'm just going to create a restart, specifying the parent again. I'm going to change, well, I actually don't need to change the start time and first stage and stuff, because but they're all set to tilde in the parent, which means that we'll pick up from the parent where we finished. I'm just going to run one stage in the restart with two wave cycles. I'm going to save that as restart. I'm going to look at the data, which is, it's The only thing I've changed is I just want a single stage. And if I, again, if I add this, run it, I think now you can see that the parent was run first before the restart. If I load the restart and look at a time history, including the parents of tension at the top end, and rather surprisingly, I suppose, I see a big spike. And this was intentional. I've made a mistake, an intentional mistake. I made it on purpose. And I've done this to highlight a very common mistake that we, myself and all my colleagues have made over and over and over again while we've been developing this. I think we're getting to the stage now, after months working with the feature, that we're making it less frequently, but we still every now and again make this mistake. And the mistake is simply that I have left statics enabled. Actually, it's easy to see if I reset it. I have left statics enabled in the restart analysis, and the reason this causes a problem is in the restart I want to pick up all the nodes, positions, velocities, accelerations, any seabed friction state, anything like that. I want to pick that up and start my restart analysis with the model in that state. But instead, I've said no. Go and put the model in a static equilibrium and then start dynamics, and that's why we get the kick. So it's very common when you want to do a dynamic restart from a dynamic parent, or indeed a dynamic restart from a static parent. You want to go and disable statics. So that's a common step to apply in the first restart of a chain. Now I can run the restart again and look at the same graph, and now everything's continuous. Okay, let's go back and let's change some data that's not really simulation data. Let's change some model properties. I'm going to change the bend stiffness and double it from 120 to 240, which is quite a wild thing to do in a restart analysis. Let's see what happens when I do that. And I'm going to look at bend moment and tension time histories. And first of all, I see at the point where the restart happens, I have some noise. I've basically introduced a transient by making such a gross property change. So, not surprising, there's a transient. We see some noise in our output. It shakes out after 4 or 5 seconds pretty quickly. Bend moment itself, well, bend moment, we've doubled bend moment. The actual shape of this line is really actually controlled by tension. So effectively, all we're doing basically is just doubling the bend moment by doubling the bend stiffness. And you can see that in the output here. Now we have tried pretty hard to be as flexible as possible in letting you change data. So if I come to the documentation and in the document, the topic on restart analysis, there's a section listing features that are blocked. So you can't at the moment use line feeding in restarts, and there's a whole bunch of data items that you can't change in a restart. You can't change the units in a restart analysis. Now, I don't think that's really a great loss. That would be incredibly confusing, and we've just decided not to try and implement that. You can't change nonlinear solid model data. That's something that we would like to relax in a future release. You can't change line and turbine segmentation and discretization, and there's a handful of other things that cannot be changed. But actually, this list is pretty small. I think when we set out on this feature, we had in mind that we would err on the side of blocking more things in the first release and relaxing them later on. But in the end, we've managed to relax and allow changes to almost all data items right from the very first release, which is quite nice. It's one of the reasons why the feature has taken a little bit longer to develop. Now, some of these restrictions will be lifted, hopefully in future releases. In particular, I think it would be very valuable to be able to use line feeding and restarts in tandem. So hopefully in future releases we will tackle that. Right. My next example is a little bit more complex, but also a little bit more realistic. So these two examples have been quite basic and quite hopefully getting across some concepts. I'm now going to try and have a couple of more realistic examples. And this example looks at seabed friction and how that some scenarios can be modeled with restarts. And I'm going to start by showing a dynamic analysis of the scenario that I want to model. So what I have here is a line mostly on the seabed, partially lifted up at one end, and in the course of the analysis, I swing the end that's lifted up, swing it through a circular arc through 90 degrees. If I look at a replay with trails on, probably need to speed it up, and you can see what happens. And the line is bowed out here because I've got seabed friction acting. And the history of seabed friction is important in determining the final configuration. So as the line swings around through 90 degrees, friction acts to resist, it sort of pulls back from towards where the line has just come from. So as the line moves round, the direction in which the friction acts also changes. So I'm going to try and replicate this scenario using a series of static restarts. And I'm just going to also take the opportunity to demonstrate some of the automation that I talked about before. So what I have is, let me see, I have an initial model, statics is enabled, I have 0, 0. When I look at that, if I look at the content of it, it makes two changes. It changes the step 1 statics policy to none and the line's seabed friction policy to restart. I'll look at those in situ. It turns out that for a series of static restarts where I have performed a static analysis and my restart is quite similar to the previous, the parent analysis, it's actually better to disable step 1 and step 2 statics and go straight into whole system statics. It turns out, well, it's better in this model. For some models that might not be the case, but in this model it turns out that the convergence is a little bit quicker. So sometimes you'll be tweaking these settings when you're doing these chains of static restarts. And the other change that's actually really important and crucial for this example is the seabed friction policy. Now, this is the data item that was formerly a Boolean. Do you want to include seabed friction in statics? And if you did, then you would get this as-laid approach where you specify a lay azimuth and an as-laid tension, and the seabed friction acts towards that as-laid state. And you can still do restarts where you use as-laid policy. But in my case, I want a different approach. I want each restart to use the history of seabed friction. I want each restart to pick up the current friction or the friction state from the previous analysis and use that instead. That allows me to have the line track round and as it's swept through and keep that history. And then I'm going to look at my automation. And my automation is this Excel spreadsheet. This is the standard OrcaFlex Excel sheet, the pre-processing sheet for text data files. And I'm going to do a static analysis, one analysis for each degree. So I'm going to do 90 analyses through 1 through 90 degrees of my arc. The end position here, if you can see by the formula, it's just cos and sine, classic trigonometry. I have to specify the file name for this analysis and also what its parent model is. And I'm using a template file. The template file is here. This is the file. Each of these placeholders, percent parent, percent angle, etc., will be replaced by values from this table. This file, you can generate it in the GUI now in OrcaFlex. I mean, when you generate in the GUI, you won't have these percent values in. So you generate it by putting some actual numbers in and then replacing them with the placeholders. That's how it works. If I come to here, I'm having to just hide. I'm having to move around because my zoom toolbar is getting in the way. But if I click on create text data files, then what I see now is a whole load of files that have just been created, YAML files. Let's just pick one. And each one has had the values in the template replaced by values by a particular row of this table. I can run this analysis now. It takes a little while, but it's not that long. I've added, remember I just selected the last one, the 90-degree one, and all the parents have been added, and now they run in the right order. It's just a static analysis, so it chugs through quite quickly. But it does indeed run sequentially because each file depends on the previous one. If you had multiple chains that were independent, then you would get some benefit from parallel processing. Okay, we're nearly there. Right, let me load number 90. And if I look at a restart replay, I don't want the initial analysis. Okay, it's going hideously fast because my dynamic analysis, I had to speed it up. Now, this is a replay. Normally replays involve time, and I can actually also look at a time history of tension, and this looks like a time history. Well, what is that time value? Well, in this case, what I actually did, if you notice, I gave a start time for the model. I can see it in the data. A static analysis can have a start time. And here I'm just using the start time just as a label. So it means when I look at a time history, I can actually, the time represents the angle. So that can be quite an effective way to look at results where I've basically reused our ability to plot time histories and repurposed it for static analyses. And the final thing I'm going to show here, before I actually show some results comparisons, is the same approach but using lay azimuth. So this is the feature that has been in OrcaFlex for a very long time. This analysis I'm doing as laid, lay azimuth 0 degrees, so it's along the x-axis. It's not a restart analysis, it's just a single shot static analysis. And the lines, each node has a friction target position that is where it was in the reset state. So, well, yeah, it's not great. It's along this x-axis. So the nodes act towards the x-axis. And when I look at some results, on the x-axis I have arc length, on the y-axis I have tension. This is at the 90-degree point, and I can see that the static restart and dynamic option in blue and red respectively, they line up very, very, very nicely, and we're very happy with those results. The lay azimuth single statics approach is nowhere near, and it's just wrong. Now that doesn't mean that the lay azimuth is not useful. It's wrong in this case because what I'm asking of it is unrealistic. You know, to have such a gross geometry change, I've swung it through 90 degrees, that's too much. The algorithm can't handle that. Were I to do it through a more reasonable amount, I would do the same comparison where instead of going 90 degrees, I go 10 degrees. Then we see static restarts and the lay azimuth single statics agree very nicely. So lay azimuth as laid friction is useful. It's not something that I'm saying you should abandon, but you have to know where it's applicable. And where it's not applicable now, we have static restarts to fill that gap. Just for a bit of fun, I can also show, let me see. Yeah, I made, last night, I hacked a bit of code together to draw to visualize the friction target positions, and you can't do this yourself in OrcaFlex. I was only able to do it because I have the source code and I can hack it. And if I look at the two things we were comparing, this is the static restarts, and as you see, if I look through the replay, we can see, yeah, I'm just going to disable trails. Actually, no, trails are all right here, aren't they? Now, just forget, at the start you see, this is just because I've lashed this together quickly. You see some of these angles, some of these lines are pointing in the wrong direction. That's just because those nodes haven't really moved yet, and it's an undefined direction, and I've not really coded this properly. As I said, I lashed it up in 2 minutes last night. But these directions are all accurate, and as we move through, you see that the direction in which friction is acting is turning as the whole line turns. Whereas if I use the lay azimuth, then you see it hasn't turned; it's acting right back to this as laid position on the x-axis. So that explains, hopefully, very clearly why the two didn't line up. Right, one final example to show you, and this is going to have some dynamic restarts, and I'm going to embed a nonlinear wave in the middle of an irregular wave, which might seem like an odd thing to do, but I'll explain why. What we have here is a fixed foundation offshore wind turbine. It's a monopile, and the IEC design code for these things, it has a requirement that you assess the impact of extreme waves, accounting for both the stochastic nature of the environmental loading and the nonlinear nature of the waves. Now, irregular waves are typically modeled using an ensemble of linear wave components. So it's quite hard to meet this requirement, and the code suggests actually embedding a nonlinear wave into the middle of an irregular wave train. And you just simply would not have been able to do this in previous versions of OrcaFlex. But with dynamic restarts, we can now do this. Setting up the data is a little bit fiddly. Once you know how to do it, it's not that difficult. And I'm going to use a model that has been prepared already, actually by a colleague, so I really had it easy with this one. Now we have a John swap wave, and our simulation duration after the build-up period is 100 seconds. And if we go back to the environment data, you can see we've chosen a particular time origin. And the reason we've chosen that time origin is that we are looking to achieve this. We are looking to, so this is our irregular wave, and we've chosen the time origin so that we end up at 100 seconds in this trough. And this trough happens to have the same elevation as the non-linear wave that we're looking to match. And the reason we match on troughs is that it's easier to find a matching trough than a matching peak, because the nature of non-linear waves is that the peak elevation tends to be higher above the mean water level than the trough elevation is below it. So we match the peak, and if I go back to OrcaFlex, if I look at the second model in the chain, then I've changed, or the data has been changed to use a non-linear regular wave, HS around 12 seconds and a period of 9.8. That's this wave that's marked in orange. Okay, and in the final analysis in the chain, number 3, we switch back to a John swap. Now, when we switch back, so when we switch over to nonlinear, we've arranged that the elevation matches quite nicely. When we switch back, if we just switch back into the same original wave train, we're going to have a huge discontinuity here. So what we do, it's quite nifty, we cut the irregular wave at time t equals 100, and we shift it forwards by 9.8 seconds so that we land back on our original trough, and we carry on where we left off, having had just a minor excursion for this nonlinear wave. So that gives us the opportunity to achieve close to continuity, at least in elevation. And that shift is achieved here, this 9.8 wave time origin. We've restored the original simulation time origin, and we've applied an extra time origin shift there on the wave. So that, once you get your head around how to do it, it's actually quite nifty, and actually not that difficult. When I look at the results, I can see, at least for the environment, well, this is the overall wave elevation. I've zoomed in a bit here for, if I look closely, I can see a slight discontinuity. These troughs match pretty well. The sea velocity and acceleration, the kinematics, they don't match as well, because trying to match linear and non-linear, well, we're not expecting that to match exactly. And likewise, when we look at the results on the monopile, we can see inertia force, drag force, Morrison force. There's a discontinuity in each of these at the joins. But the shear force and the bend moment, they don't seem too bad, and the response of the tower, the end of the tower, I think that's the top of the tower, isn't it? It's pretty neat. So, I mean, in an ideal world, I think we'd like to be able to blend these wave trains into each other, and that's another feature that we're thinking about and looking at for the future. But for the moment, you have to live with these discontinuities. That's not going to be a mainstream application, that particular application, for a great many of our users. Some of our users do this kind of thing, but not all. But I suppose what I'm trying to get across here is the ability to to do restarts where you change the environment is really quite powerful, and it's something that's been asked for in a lot of different contexts over the years. And for years and years we've said, well, we need restarts for that, we need restarts for that, and finally we have them. So I think that's where I'll wrap things up. We're going to hang around a little bit at the end to answer some any further questions. So I'll bring James and James in for that in a minute. Yeah, it's been a huge job for us with to add this new feature, restarts. We're very excited about it. We hope that it's very useful for others. But it has been a big job, and it's kind of touched every aspect of the code base. One of the biggest and hardest developments we've ever done. And because of that, we anticipate that there may be a few issues still remaining. We've done months and months of testing, but I'm sure we've not found every single issue. So just be cautious when you start using it. Keep your eyes open for anything suspicious, and let us know if you found anything wrong. And also give us some feedback if you can. The feedback is always very valuable and very important for these user group meetings. In a minute, I will. After the meeting, you will get an email with a URL, an address for some feedback forms. So we definitely want to hear from feedback both on how you thought the webinars have gone, and also on potential developments to the software, opinions on that. And you can always email us at any time with that kind of stuff. So yeah, at this point I'm gonna stop my screen share, bring in James and James, and if there's any more questions to deal with, we can do that now. And if anyone wants to ask a question verbally, then we can do that. If you raise a hand in order to do that, then I can unmute you. The feedback form, I'll just put the feedback form into chat. So, and if you're attending any of the other webinars, it's probably best if you wait until you've attended the last one before you fill in the feedback form, and you can do a single form for everything, maybe. Right. Well, how are we doing with questions? Are these features and parameters presented included in the Python API? Yes, all of this is available through the API. We actually test. We do our testing through Python through the API. So if we didn't support it in the API, then we wouldn't be able to test it. And adding support for this in the API was one of the very first parts of the development, actually, to enable us to test it. So yeah, all of that can be done that way. In a batch run, does it run the parent once for each instance of the children? Okay, so I guess your question there is once or for each instance of the children. So what happens is, if you have a parent that has multiple children, the parent is run once, and then the children are run, and then any of their children are run, and so on. So, if you have a parent that's referred to by multiple children, then that parent will only be analyzed once in the batch form. Right. If you've got any more questions, then yeah, now's your chance to ask them. It's really we had some really good questions this morning when we did the same session. So I'm sure some of you may be sitting there waiting. There's still 125 people here apparently. So if you have anything, let us know. If you want to ask your question verbally, then just put your hand up. I'll let you do it that way. Okay, blending between restarts sounds really useful. When will that occur? I don't know when it'll occur. I think we still haven't got around to deciding when, what's going to be in the next release. It's going to be a smaller release than normal anyway, so I can't answer that. But I think it'll depend on how much feedback we get. If we get a lot of feedback suggesting it would be really valuable to users, then we'll do it sooner rather than later. Right, I can see someone with the hand up, so I'm going to let Don unmute and ask a question. This is quite exciting. We didn't get any of this morning, so let's see if it works. No, maybe that was a false alarm. Okay. Well, I'll go back to the next question in the Q&A. In a batch, would it have to rerun the statics each time, even if the change of values don't affect the static solve? Yeah. Okay. So, I guess what you might be getting at is, imagine you have a series of dynamic analyses that all start from the same static solution. So, and the way the program is at the moment, what happens is the batch, the analysis performs a static again every single time, and you repeat the same static calculation over and over again. Now, with restarts, you can have each of the dynamic analyses being dynamics only, a restart from the same statics only parent model. So the parent will be run once that does the static analysis, and then all the dynamics will branch off that at the same time. I think that's the question you're asking, but if I've misinterpreted, yeah, ask again if I've misinterpreted that. This question we had again and again this morning, so it's nice to see the same questions arriving. Can we restart from a parent in the middle of the parent analysis? And that's again something that we've thought about, and we think we want to do this, but we haven't had time to do it in this version. So this is where maybe you wish to restart from partway through a parent analysis, or maybe you have a parent analysis and you want to branch off at 3 different points within that parent. That's something that I think we will again introduce in a future release, but we're not there yet. It requires a little bit of development on our side, but it's not going to be too onerous. But yeah, we just ran out of time. Can we use OrcaFlex and restart analysis to map a quasi-static model for a mooring system? I must admit I don't quite understand that question. I don't know, James Pell, do you understand that question?
Not quite, unless it's possibly referring to generating the curves through multiple static restarts, static steps. Is that possibly what you're referring to, Bruno?
Maybe if we aren't succeeding in answering that one live, then maybe you could post the question, send us an email with the question, and we can try and work it out. Can a restart use a failed simulation as a parent? This is another question that was related to one I just answered, I suppose, and we had the same one again this morning, and the answer again is no. What we need to do is we need to have the ability to restart from partway through a simulation. I mean, you wouldn't want to restart from the very end of a failed simulation where the model has become unstable. You'd want to go back little bit in time, and that's something that I think we will look to do. I mean, it's a really useful idea if a simulation has failed because maybe you just needed to reduce the time step a little bit. At the moment, you can't. You've done a huge amount of analysis and you're just missing the last few seconds because of a convergence failure. That's something that we'd like to be able to do, but as of now, you can't. But I would imagine that'll be something we work on in the next release. Any more questions? You've got a captive audience here, so go for it and ask if you can. Right. Do restarts allow for new objects to be added? Yes. Added or deleted. Can we add more length or sections to an existing line or insert a section within a line? No. That's one of the things that you can't do at the moment. And the reason for that is that we wouldn't have any good way to know where to start those, those new, new nodes that you've added. What I suppose you could do is you could add. You can't do this at the moment, but no, maybe you can do this at the moment. You could create a new line and connect the two lines together. And solve statics for the newly added part of a line. But I'm not even sure whether that would necessarily give you something terribly useful. So I think probably for that kind of thing, for when we're looking about rediscretization or adding new nodes within a line, then we would probably need to talk to you and try and understand the application you have in mind, so we can get a better feel for how we might support and add features to help you solve the problem. So this is one of those questions where the answer is no at the moment, but we need to understand the motivation, and then we can see if we can come up with a solution. Could you accidentally reset to default an object like a vessel or an REO table? I guess you mean the context menu item where you right click on a data item and say reset to default. I mean, yes, you could accidentally do that. It's readily undone using undo or cancelling the edit. But yeah, we can all accidentally change things and click on things by accident. Is it possible to save a certain instant during an R simulation as a new parent model file? I mean, that's kind of the same question that I think was asked earlier, where can we restart partway through a simulation file? So not yet, but hopefully in a future release. Can we have an Orcaina shirt? No. Only for the privileged few that get to work for us get to have the Orcaina shirt. I would point out that James here, who's showing off his Orcaina shirt, is using the old logo, and our guy in charge of marketing and branding spotted it instantly and prodded him and chided him about this. So, James, you look a hangdog look as I'm dumping on you again. Yeah, we've got to follow up on that quasi-dynamic, but I don't think I can really answer that very easily. Can you maybe, Bruno? Can you send us an email with that? And it's probably better to do that through email. It's sufficiently complex that I don't think we can answer it quickly. Can you use external functions to stop a simulation to act as a start point for a restart? again, I think no, because then you'd end up with a simulation. Well, okay, maybe you could. If your external function was extending the simulation as it was going along, and then at the end of it deciding whether or not to extend it again, then you'd end up with a simulation which had run to completion. And the rule here is you can only restart from a simulation that has run from completion given its input data. So if you have an external function that pauses a simulation partway through its nominal data, then you can't restart from that. But if you have an external function that maybe runs a couple of seconds and then decides whether or not to continue, extend and run a bit more, then you'd end up with a file that was run to completion, and you could restart from that. Again, I suspect that would be something where, yeah, I mean, really, I suspect what you actually want is you want for us to do the development that isn't there now, that allows you to restart from specified points within the simulation. These are good questions. Right, we'll give it another 30 seconds or so, and if nothing more comes in at that point, then we'll call it a wrap. I don't know whether I've said everything I needed to say. Yeah, I think so. Two more questions. Smoothing regular wave in between irregular wave, it would be good to have a smooth change from one irregular to another. Yeah, I mean, I think if we go into and we do some sort of blending of transitioning in a dynamic restart, then yes, it would be hopefully quite general purpose and allow you to blend from one irregular wave to another one. Can we restart model structure landing? So structure landing will destroy some soil and the restart will start from disturbed soil. Yeah, that's I guess that's a reference to our nonlinear soil model, which is a sort of hysteretic model. And at the moment you can't modify that. You can't modify the data in a restart. But what you can do is you can, I suppose, have constant soil model data, and you can maybe sort of cycle the soil to get it into a deformed state, and then restart. Maybe restart from that cycled deformed state. So depending exactly what you want to do, that might be possible now. But if not, Gunnar, then maybe let us know by email more details of what you're trying to model, and we can use that to guide how we open up modification to soil model data in a restart, which is one of those things that I believe we can allow, but we didn't have the time to do it for this release. Well, my 30-second timer has been reset now, so yeah, once we go away, we aren't going to come back. So this is your last call for questions at the Orcana user group webinar. I need a going, gone, don't I? Okay, looks like. Oh, here we go. One more question. Can you simulate a ramp blending by having lots of restarts with a short time on each and a small change of parameter? I mean, yes, I think you could do that. I don't know. You'd have to automate that heavily to do that, but yeah, you could absolutely do that. And maybe if it's a loading that you're varying, you could specify by time history to do the blend yourself. So for sure, there's things you can do with a series of short restarts to sort of fake a blending, but until we can add some more automated ways to do that. Can we use restarts with J-tube pull-in? Yeah. I mean, I think certainly that's a feature where it's going to be very valuable. I know one of the things that that you can end up doing is sort of doing a pull-in operation, and then maybe you want to run a series of different dynamic loading cases on top of that, and the pull-in operation can be quite awkward and time-consuming to do. Well, again, that's a situation where you might have that maybe the dynamic pull-in is done once, and then you branch off to have a series of different child restarts with different environmental models. So there's lots of opportunities, I think, to take advantage of restarts with that type of analysis. I think even though there were slightly fewer numbers in this meeting, you've asked more questions at the end than the previous meeting. So you can all give yourselves a pat on the back for doing well in that regard. But I think it looks like we're out of questions here. So I'm going to wrap it up here. Thank you very much for attending. I've been blown away by the number of people that have turned up to these meetings. I really hope it's been useful. Look forward to seeing any feedback you have in due course. And if you're attending any of the meetings later in the week, then I look forward to seeing you there as well. Okay, thank you very much, and goodbye, everyone.